Welcome to GeoDesignPro. Today we are going to take a fast peek under the hood and touch on all the various features included and at your disposal. We hope you'll see the value in giving it a try. Menu bar. Your workspace. Manage other users to have access to your project files. Current project. Displays the name of the current open project. New. Start a new project. We'll need to confirm to avoid losing work. Open. Open an existing project, either from the cloud or a local .json file. Save. Save the project on your account in the cloud, great for accessing with a different computer, or locally as a .json file. Right side menu autosave. Indicates time of last autosave. Docs. Access documents describing the various features in GeoDesignPro. Order materials. Opens in a new tab. Phoenix Energy Supply website where you can access additional product information as well as order materials. Support. Access your account information as well as submit messages directly to our support team. Your display name. Access your account, change password, and log out. Tabs project. Overall project-related information. Zones. Input the zone loads and zone-specific piping data as well as estimate load diversity. Loop field. Enter all loop field data, design reverse return manifold, export CAD drawing, and evaluate loop field balance. Distribution. Describe the interior piping system that is providing fluid to all the heat pumps. Flow center. Evaluate need for and size of expansion tank as well as identify viable flow centers. Schedule. Generate and configure heat pump schedule. BOM. Provided as a convenience to create a bill of materials that can be used as a budgeting tool. Report. Utilize an AI-generated report reflecting what constitutes your project design. Feedback. As a system designer, we are making it easy for you to submit feedback regarding GeoDesignPro. Project name. Totally up to your discretion, but we'll also create a default file name when saving the file. Project address and client-related fields for your convenience. Min and max entering water temperature. For your records and antifreeze properties will be calculated at the minimum specified EWT. We'll also provide basis for expansion tank calculations. Flow, GPM/ton. This value will create a default flow rate for each heat pump in the Zones tab, which can be changed individually by heat pump. Many projects can be positively impacted by considering as low as 2.25 GPM/ton from a pumping energy and overall pump sizing perspective. Changing this value will reset all heat pump flow rates, overriding any manually entered values. Diversity. This value will reduce the total system design flow rate and corresponding pressure drop by recognizing that there is inherent oversizing of heat pumps and that even on a design day, there will be a degree of heat pump cycling to meet the design zone loads, as well as the reality that the sum of all zone peak loads is greater than the peak block load, all contributing to the diversity. Overall system performance and cost-effectiveness will be improved when a designer understands and captures the benefits of diversity. Will be discussed further in the Zones tab. Antifreeze allows user to specify the type and desired freeze point. Choices included none, propylene glycol, methanol, and ethanol. Default manufacturer and series. Allows user to specify the default heat pump manufacturer and series of heat pumps. This is used as a convenience to pre-populate fields in the Zones tab, which can be changed for individual zones. Fluid properties. These are the fluid properties being used in the Darcy-Weisbach pressure drop calculations, which is the gold standard for calculating head loss in a pipe. It is generally considered more accurate and more flexible than the Hayes and Williams equation because it accounts for various flow regimes and pipe roughness. The user can override these values if other antifreeze options are used and can easily reset them to the calculated values based on the specified antifreeze and freeze point. Live results. The live results column will allow for immediate and live feedback, reflecting how each change in any of the various parameters will affect the many aspects of your system. Of course, it will only be meaningful as you get close to finalizing your design. Logos and links. They are provided for you to have quick access to both residential and commercial heat pumps provided by these manufacturers. Loop field analysis only option. For those users who may not know specific zone data, this feature allows users to specify a design flow rate, an interior pressure drop allowance, as well as an estimated volume of the interior part of the system. This will allow user to focus on designing loop field details. Enable template method. This mode allows user to simply input just the different heat pumps used on a project and using the distribution tab to build out the entire system by dragging and copying from the list of unique heat pumps to easily handle large projects that use a large number of identical heat pumps. Import zone data. An Excel spreadsheet zone template can be exported, completed in Excel, and then imported. Manage custom. This allows users to manage a list of heat pumps that are not included in GeoDesignPro. User can specify model name, series name, nominal tons, rated flow, pressure drop, heating capacity, cooling capacity, budget price, voltage, min circuit amps, max overcurrent protection, and full load amps. User can also export and import this data. Add zone. This triggers the process of adding a zone. Tag. The default of HP hashtag tag will be used incrementally as zones are added, but can be overridden by the user. Zone name. The default of zone number will be used incrementally as zones are added, but can be overridden by the user. Heat and cool zone loads. Enter the peak zone loads in kilo BTU per hour. Heat pump manufacturer. This field is pre-populated based on the entry in the Projects tab, but can be changed on a zone-by-zone basis. In addition to preloaded heat pump manufacturers, choices will include custom, allowing user to have a library of custom-defined heat pumps. Heat pump series. This field is pre-populated based on the entry in the Projects tab, but can be changed on a zone-by-zone basis. Heat pump model. This field is pre-populated based on meeting the most demanding load, but can be overridden by the user as this note indicates. Selections are based on closed-loop AHRI ratings only. GPM. This field is pre-populated based on GPM per ton entered on the Projects tab and the nominal tonnage of the selected model, but can be changed on a zone-by-zone basis. If the GPM per ton on the Project tab is changed, all heat pump flow rates will be reset, overriding any manual entries. Pipe material. This field is pre-populated with HDPE DR11, as it is considered the ideal choice for most applications but can be overridden by the user. Other choices include copper, PVC, steel, PEX, PPR, and hose. Pipe nominal diameter. This field will display a default calculated value that is the largest size that has a velocity of at least 1.5 feet per second, indicated with a yellow background. User can change the value, will change to bold font and green background. Smaller pipe will result in increased pressure drop, while larger pipe may lead to air accumulating in the pipe as well as higher cost. Pipe length. This value needs to reflect supply, or one-way actual length of pipe that is handling the specified flow for that circuit. Elbows. This value should indicate the number of elbows on just the supply. The program will assume the return piping is identical. Two-way valve. All multi-heat pump systems should use a two-way valve to prevent flow through the heat pump when not needed. Enter the CV, flow coefficient, for the selected valve. Generally, a valve with a CV equals 2 times the GPM is considered a good choice. Strainer/other. Heat pumps with brazed plate heat exchangers typically require a strainer, so this field will allow you to account for it by entering the CV. can also be used for any other valves or other flow-restricting device. BAL, or balance. This field indicates which circuit is not in need of a balance valve, open, and adapts to how the distribution piping is configured. This allows the astute designer to balance the system through piping design and avoid the use of balance valves on every circuit and the associated 5 to 10 extra feet of head on the system requirements. A CV value in the STR column can be used to dial in the extra pressure drop to help in selecting a balance valve on the circuits where they are needed. Pressure drop breakdown. This color-coded scheme illustrates where the pressure drop is being created. Heat pump, red, piping, blue, and strainer balance valve, black. A value is displayed with a mouse over. Action icons. These icons allow user to quickly add comments or notes relevant to that zone, duplicate a specifiable number of times, or delete a zone. Diversity estimators. One of the best ways to deliver high performance at the lowest cost is to capture the inherent load diversity that exists in a project by designing for the realistic peak load and not the imaginary worst-case scenario. These tools help quantify by comparing the peak block load to the total installed capacity. Use this as a guide to enter a value on the Projects tab to reduce your total peak design flow rate. Example of a larger job. Site and geological parameters. These are not used by the software but will be referenced in the AI-generated report. Loop field pipe sizing mode auto or manual allows the program to calculate optimum sizing or allow user to specify pipe diameters. Loop field data. These values reflect a live update as parameters are changed. Horizontal. By checking this box, a horizontal loop can be modeled, otherwise a vertical loop is assumed. This can be applied on a group-by-group basis, allowing loop fields to consist of both vertical and horizontal groups. Number of bores. Enter the number of bores in a group. If more than one loop per bore, simply enter the number of loops per bore times the number of bores. For horizontal, this field will ask for the number of coils. Loop pipe diameter and DR. Enter the nominal HDPE pipe diameter and the diameter ratio. Average depth. Enter the average depth of all the bores in that group. For horizontal, this field will require loop coil length. Manifold type. Select from the following: short, compact. These are typically very short, consisting of back-to-back T's having negligible volume and pressure drop compared to the coil or loop. Reverse return. These consist of longer runs of pipe with the return manifold installed in the opposite direction of the supply manifold. This design requires diligence in selecting the appropriate diameter in each section to properly manage purging or flushing requirements. Tap spacing. This entry becomes a default spacing between the taps to connect to each loop. However, every section can be overridden by the user. Runout length. Enter the length of pipe one way that will be carrying the total flow for that group, typically from an interior valved manifold to the connection to the buried manifold. When using a reverse return manifold, the total length should reflect the average length, or in other words, the length to the middle of the manifold. Section A. Diameter and DR. Enter the nominal HDPE pipe diameter and diameter ratio. Length will be the total minus length of Section B, otherwise will equal the total. Section B. Length, diameter, and DR. These values will allow the user to create a perfectly balanced loop field by using lengths of different diameter pipes, resulting in balance while also saving money on pipe, antifreeze, and the penalty of balance valves. Runout pipe calculated values. These values reflect the calculated values for the supply runout pipe only. The velocity will show velocity in Section A and velocity in Section B if length of B is greater than 0, and the values for volume and pressure drop are doubled and are reflected in the system totals to account for the return side. User Advisor Note. Clarifying that the volume and pressure drop of the supply runout pipe is doubled to account for the return pipe and is reflected in the totals. Reverse return. The segments start after the first tee, and the flow reflects the remaining flow after supplying the first loop. The default spacing is automatically entered and can be changed by user. This is where the magic happens. The proper diameter is pre-calculated based on maintaining a velocity of at least 1.5 feet per second at the design flow. These sizes can be changed by the user with the caution that using a larger diameter will increase purging flow requirements and may lead to potential air traps, while smaller will slightly increase system pressure drop. User can change the DR to improve pressure drop and lower cost. Typically, DR11 is used for 2 inches and smaller, while DR 13.5 and 15 are used for larger sizes. The results are immediately expressed and display the velocity and pressure drop of each section. It should be noted that the extra pressure drop from the run of the tee is included in this manifold pressure drop, while the pressure drop of the branch is added to the loop coil pressure drop. Generate CAD manifold. When activated, a pop-up window will display a drawing of the reverse return manifold. This drawing displays all the data that was specified by user, and the software identifies the required fittings to assemble this in the field. This drawing can be exported as a DXF file suitable to be inserted into project drawings. Batch duplicate. This allows user to quickly duplicate a group a specified number of times and subsequently edit the runout length and/or other details to each group. When there are multiple groups, the actual expected flow rate due to unavoidable differences is compared to the design flow, so the user can make informed decisions regarding taking steps to improve balance. The Reynolds number is also presented for the loops in each group at the actual expected flows. If it is deemed required to improve balance, these recommendations are provided to dial in near-perfect balance without the enormous penalty of blindly adding balance valves to the interior valved manifold. Manifold and header design. Also presented is a recommended interior valved manifold design. Due to the much shorter distances, a smaller circuit size is often recommended with very little performance impact but a significant cost reduction. Consequently, reducing the runout pipe to a smaller diameter just prior to the wall penetration to enter the mechanical space is considered a good practice. The manifold length, volume, and pressure drop are also calculated. Purging requirements. Also presented are the worst-case purging requirements in terms of flow rate and expected pressure drop. Defining the distribution method. Any pipe that is feeding multiple heat pumps is part of the distribution system. Enter the following: number of circuits, excluding any sub-circuits, min and max velocity. This facilitates the default diameter selection algorithm. Select type via distribution circuits, most common for larger systems. Home run, where there is one very short distribution manifold and each zone heat pump circuit as specified in the Zone tab is defined as a home run circuit. Default interior pipe material that may be overridden for any section of pipe. Common piping. Any pipe that is handling 100% of the system flow, both supply and return, such as from the valved interior manifold to the flow center and from the flow center to the first point of diverging distribution. Enter the total number of elbows and valves to improve accuracy. Assume 2 inches and less to be full port ball valves and 2.5 inches and larger to be readily available butterfly valves. Unassigned zones. Initially, all zone tags will appear in this area. By Control left mouse click, user can select the appropriate tags and drag and drop them into the appropriate circuit for further modeling. Handy tools. Naming rule will facilitate a naming protocol to include floor and/or room number to better track your work. Return all will return all tags back to the unassigned area. Select All will highlight all tags in the unassigned area for ease of dragging and dropping. Sub-circuits. This feature allows user to incorporate a branch off the given circuit that is serving more than one heat pump. Circuit details. The input describes the upstream pipe back to the previous node. User can specify the pipe material, number of elbows, the actual length of pipe, and the diameter. The recommended diameter based on achieving the lowest velocity in the specified range is displayed as the default calculated value. The interior pressure drop and volume reflect double the values here to account for a virtually identical return manifold. Home run option. The home run option reflects a design approach where each heat pump is connected to a short distribution manifold. The entire heat pump circuit is defined in the Zones tab and is reflected here with the ability to characterize the runout piping serving one or more of these short distribution manifolds. This area allows user to specify the runout pipe material, length, number of elbows, and diameter, as well as specify the manifold material and connection or barrel size. The calculated drop and volume is doubled and is reflected in the system totals. This area reflects what was specified in the Zones tab, and any required changes would have to be entered on the Zones tab. These values are not doubled, as both the supply and return side have been accounted for in the Zones tab. Zones tab, Template Mode. Similar to adding zones in template mode, you add heat pump types used in the project as an inventory that is used in the Distribution tab to develop full system of zones. In this example, we have GeoStar Aston Compact Water-to-Air heat pumps from 3/4 to 2 ton sizes available to draw from. Distribution, Template Mode. The unassigned area now contains the types created in the Zones tab, allowing the user to drag and copy into various circuits, building a list of all zones. Here we have drawn 4 3/4 ton units to handle the first 4 floors, and used a 1 ton to handle the 5th floor to characterize a vertical riser that may be typical in a 5-story apartment building. These zones were automatically added to the Zones tab. Here are the zones that were created in the Zones tab, and you will notice the appending of the room number in the zone description, a feature that can be modified with the Naming Rules tool in the Distribution tab. This illustrates the naming rule options to facilitate organization. Expansion tank sizing. Located in the Flow Center tab is the expansion tank sizing feature that incorporates both the thermal expansion coefficients and the modulus of elasticity of each length and type of pipe used in the system. Filter option. This area displays all the Flow Center types and can be used to filter the list of viable options. Viable Flow Center options. Based on type filter, the viable flow centers are listed illustrating the type, the model number, the degree of redundancy, none, partial, full, the description, the head capacity at the system flow rate, as well as the list price. A checkbox on the left allows user to select a model that will be carried into the Bill of Material (BOM) tab. Collapsed schedule option. This feature allows user to have a short schedule of heat pumps where only the different types of heat pumps are listed. When not selected, the schedule will list every zone in the project. Configure. This feature allows user to fully define all the options and accessories associated with that particular heat pump. This allows for a fully developed model number, the electrical data for that model, as well as a list price of the heat pump and accessories. Here is a before and after image illustrating how the full model number can easily be developed by selecting from a drop-down menu of those multiple choice options available for that specific series and size of heat pump. After configuring the full model number, the corresponding electrical data for that specific heat pump are displayed. Export to Excel. After completing all configurations, user can export the schedule to an Excel file. Bill of Material. Although not fully developed, this page will provide a material estimating tool. Report. Utilize a AI-generated narrative reflecting all the various inputs, and then export to a PDF or simply export the various tables to Excel. User feedback will be an essential ingredient for us to make GeoDesignPro the geothermal system design tool that will save time and money while also improving accuracy. We are pleased to be able to offer full access to GeoDesignPro to all who sign up at no cost.